sometimes it's easier to work with what's called the Venn diagram to work with probability problems because it's a nice visual of what's happening, and I'll walk you through it. Use them if you want. It doesn't work with in every situation, um, but what they're telling us is that they're telling us that uh, where is it? O negative blood is a universal donor, right? And they're telling us that 4% of African Americans have O blood and are Rh negative, right? So that's telling me that the probability that they have O blood and they're Rh negative, I'll just, what do I want to do? I'm going to be very lazy and just write negative, equals 0.04, or 4%, right? And then they're telling us that the probability that somebody has type O blood is 0.51. Now that includes the people that are Rh positive and Rh negative. And then the probability that, and then 5 to 10% of African Americans have the Rh negative factor. So the probability of negative equals 0.1. So they're going to ask us to do some calculations here. Well, first off, this probability of type O, they told us that's 0.51, and the probability of Rh negative is 0.1, and then they're telling us the probability of O and Rh negative is 0.04. So that's what I wrote over there. Now, what's the probability that somebody has type O or type R? Now, if you look at Dr. Stevens' stuff and read about that's an addition rule problem. O or Rh negative, that's going to be um, probability of somebody that has O blood, type O, plus the probability that has Rh negative blood, minus the probability of both. That's what because these are not mutually exclusive, because remember, mutually exclusive are events that can't happen at the same time, and we have our O negative blood people, right? Um, to people with O negative blood. So mathematically, what we can say is here, I'm going to go probability of O or R is equals the 0.51, that's a probability of O, plus the 0.1, which is the probability of R negative, minus the probability of both. So what's that going to be? That's going to be 0.61 minus 0.04 with 61 minus 4. Is that that's 7, isn't that? Isn't that 0.57? So that's the probability that they have type O blood or type R blood, or both. So how does that graph, and I mean, maybe the addition rule formula works well for you. Graphically, what we can do when we think about the Venn diagram, we know they're telling us that 4% of people have both O and Rh negative, and that's that little lens, that area in the middle here, right here. Let me get fancy and do some shading. So that's the 0.04. And we also know the whole full circle here. I'm gonna do this. This whole full circle is the 0.51. So we don't want to count the 0.1 twice. So what we can say, if we just want the probability that somebody has, well, really, isn't this area where they're going to be O positive? Here, let me go back to ink. Isn't that really going to be O positive, because the whole green circle is type O blood. We're going to take off the probability somebody's are O negative. So that, won't this be 0.51 minus 0.04? So that's going to be 0.47. That's just O positive. That's not including O negative. We know together that's 0.51. Now, how about doing the same thing with, I know I'm going way beyond, well, I guess I'm answering I guess I'm answering the questions here. Let's set this up. I'm not maybe I'm being confusing, but I hope not. So now I'd really like to find out what probability of people are Rh negative but don't have O blood. So that's going to be um, here. Let me do some deleting here. Let me erase that blue. But I'll go with the blue ink here. So this one is going to be what is it? It's 0.1. So 10% of people have Rh negative, and 4% of those people are type O. So that means 6% of people have the Rh negative factor with the other blood types, right? A, B, and B, right? Are there any other blood types? I don't think so. So if we now to bring this back to this addition rule problem, if we add this and this and this, that's everything that's inside that circle, right? In both circles. So that's where they're getting the 0.57 from. So let's see. So we did in the Venn diagram describe the overlapping area using complete sentence. Well, that's the overlapping area is the probability, or where the probability that people are O negative, right? And then Venn diagram describe the area of the rectangle, but outside the circle in the oval using complete sentences. So both circles and oval would be, what would this be? Let me see, let me get a, I guess we'll go with gold. So this gold area is, I'm pretty sure what F is asking. But you see how if we had asked the probability that somebody has O positive blood, we would have had to do this calculation. We're taking the 0.51 and divided by, minus the 0.04. Okay, so this, what is that gold area? Isn't it all the other blood types that have the positive Rh factor? So they're A positive. So this is like whoops. It's like A positive people, B positive people, and AB positive people. That's what that would represent. So let's see. So that works. That certainly works. Maybe I'll kick this down the road a little bit and talk about conditional probabilities. So when we talk about conditional probabilities, I mean, what's the probability that somebody is O negative given that they're type O blood? That's an interesting feature. So the way you do this is the probability of both O and R negative, Rh negative, divided the probability of O. The second thing after the given line is always in the bottom. So to figure out this probability, we're going to do 0.04 divided by 0.51, and we're going to get whatever that answer is. I don't have a calculator here, and I don't want to do that by hand. Somewhere around 0.08, right? It's close. What's the probability? What's the probability that somebody has O negative blood, given that they're Rh negative? So in this case, we would say 0.04 because the probability of both is still 0.04, but the Rh negative probability is the 0.1. So won't that be 40%? That one I can do in my head. So this tells me that 40% of the people, 40% of the people that the Rh negative factor have type O blood. 60% would have the other blood types. So more than a quarter. All right, let's see. So that's the Venn diagram for that. Here they're telling us the probabilities. They're telling us the probability that somebody buys a novel equals 0.6. The probability that the customer buys a non-fiction is 0.4, and the probability that they buy both, which is symbolically, well, I don't know how to write that symbolically. I'm not going to bother. Both is 0.2. So now, if we set up a Venn diagram for this, it's going to be very similar to the one I just did. We're going to draw. We're going to label one of these novel. We'll label the other one non-fiction, and I'll abbreviate. And then what you do is you fill it in backwards. So I know that the probability of both is 0.2. Well, that's the overlapping area. And then since the probability that somebody buys a novel, that's that whole, that's that whole circle, we have to subtract off the 0.2 from the 0.6. So that tells me that 0.4 of the people buy a novel, just a novel. And the other one would be 0.4 minus the 0.2. So that's going to tell me just 0.2 or 20% of the people buy just nonfiction. And see how those add up to the different probabilities? And then what's outside that? Well, if this adds up to, so mathematically, addition rule, probability of novel or nonfiction will be the probability that somebody buys a novel plus the probability that somebody buys nonfiction. And of course, you already see we're at 100%. That there's other kind of books. So that will subtract off the probability of both, which is 0.2. So that's going to give us a probability of 0.8. So an 80% chance that people will buy a novel or a nonfiction. Are there other kind of books? Well, poetry, I guess, right? So this out here is all those other books that people could buy. Here, let me get an ink going. Out here is all the other kinds of books that people could buy. Cookbooks, poetry, what else out there? I guess how-to books, because how-to isn't really nonfiction, is it? So let's see. Let's do some calc. I'm just looking at part F. Part F is the part that I just shaded in. Well, that's the vinyl, isn't it? Because they only sell fiction, nonfiction, and vinyl. So this is the probability that they sell by vinyl. Here. So what that's going to be, since the probability of a novel or nonfiction or both is 0.8, that tells me the probability they buy vinyl is going to be 0.2 because it's 100 minus or 1 minus 0.8 or 100 minus 80%. So probability of vinyl is 0.2. All right, so we've done a Venn diagram. Find the probability the customer buys either novel or nonfiction, but not both, would be this number plus this number, so 0.6. In the Venn diagram, describe the overlapping areas of complete sentence. Well, that's the 0.2, and that's where they buy both a vinyl and not vinyl, nonfiction and fiction. What does P nonfiction line novel mean? Well, I hope you remember that what that would mean would be, here, let me slide that out of here. Because I don't think, well, maybe I'll leave it there anyways. Let me do some erasing here. Probability of nonfiction given that somebody buys a novel. So what you need to do is we're going to take the probability of both divided by the probability that they buy a novel. Basically, you're seeing what fraction, this part divided by the total of that red circle. So 0.2 divided by the 0.6. So I think that's 1/3, right? So 0.333 repeating. What's the probability? Then we're going to reverse it, right? What's the probability to buy a novel? Nice writing, Dan. Given to buy nonfiction. Well, in this case, the nonfiction will be the bottom. So that was 0.4, right? So 0.2 divided by 0.4 is going to be a half. So that's how it's kind of like this. So this conditional probability is kind of like that khaki versus jeans, or what else we were dealing with, um, cashews versus um, pistachios back in chapter 2. Very similar math. It's just what's your point of reference in this case. If you want, once you try this one, and then we'll come back and I'll show you how to do with my answer, okay? Or if you're truly lost and you still want to learn how to do this, just keep watching. Okay, so I'm gonna do, what am I gonna do? I'm gonna draw 2 overlapping circles. I'm gonna label one of them H. I'll label the other G. I'm gonna put it inside a big rectangle. I know that the probability of G is 43.43 and H is 0.42, and together they're 0.14, so that goes here. And then, uh, so then I got to subtract the 0.14 from the 43, right? So what is that? That's, let's see, that 29, so 0.29. And for the G, it's going to be 0.12 because it's got to add to 26. And then what's the probability of getting H or G? Well, I just got to add up those 3 areas. So that'd be 0.29 plus 0.14 plus 0.12. And I guess I'll do this by hand with 13, 15, carry it to 0.55. Now, what if we use the addition rule? So the probability of H minus the probability of, plus the probability of G minus the probability of both is what we need to do. So let's see how that compares. So 0.43 plus 0.26 minus 0.14. Well, let's see. This would be 69, right? And 69 minus 14 is going to be 55. So see, it's got the same answer. Easier to use the addition rule? Certainly. Well, I think certainly. Sometimes the visual helps, though. So the complement, B says the complement of H and G. Well, the complement would be H. Wouldn't that be H or G or something else? I'm thinking picture-wise. That's the complement. So won't that just be one minus 0.15 or 0.1 minus? I think it's just 1 minus 0.14. So 0.86. What's the probability of complement H or G? Well, let's do some erasing here. Well, can I undo some erasing here? Let's see if I can grab that shading. Good. So the complement of would be outside, but I won't be anywhere inside that inner circle. So I think that's going to be the 1 minus 0.55, so 0.45 would be the complement of H or G. Then they're asking us to find a couple of conditional probabilities. So probability of H given G. So remember, that's the probability of both H and G divided by the probability of G, because G's on the bottom. G's that condition. So 0.14 divided by wow, 0.26. I was going to just do that. Right? See, the total, all of G. So that's, what's that? That's uh, 7 over 13. I don't have a calculator right here. Whatever the 7 divided by 13 would be the answer. Um, E is, what's the probability of G given H? So probability of both H and G is 0.14. The probability of H is 0.43, and we divide that, and that would be that answer to that other conditional probability. Remember, see, it's always out always what you point in reference to with the conditional. Okay, hopefully that helps.